Okay, in this screencast we're going to talk a little bit about enthalpy and the terms exothermic and endothermic. After you watch this screencast, you should be able to know what enthalpy is. It's a weird term you don't normally hear out in the world. We'll be able to see how it's very closely related to just plain old heat. And we'll think about whether it can go below zero, and by the time you've watched this screencast, you should be able to provide real-world examples where the enthalpy is a better term to use rather than the heat, and it's just based on the definition. This is Screencast 12.7. Enthalpy. It's equal to the heat change at constant pressure. Really, that means the heat change when you're out in the world rather than in a closed system. This big explosion is going to generate some heat, but it's not going to increase the pressure because it has infinite volume essentially out in the world. On the other hand, this thing here is going to generate heat, but you wouldn't call it enthalpy because it's a pressurizable system. It has a limited volume, and therefore it's going to pressurize as it heats up. The difference between enthalpy and heat is they're the same if the pressure is constant. Also, we use some symbols. For enthalpy, we use the symbol delta H, which means change in enthalpy. Or if a reaction's going on, rather than say, a phase change, you'd say the change in the enthalpy for the reaction. Exothermic and endothermic. Exothermic is a common term used by scientists, and it typically means that it's giving off some heat. A wood fire is definitely exothermic. By convention, they say that delta H is negative, and technically exothermic refers to enthalpy rather than just heat. So an open system, not a pressurizable system. Also, if it's positive, they call it endothermic. Most people think of that as getting cold. And there you go. That's endothermic and exothermic.